Hello, I am Marc Landicho, and this is my presentation on the enzyme experiment number 2. So, in this experiment, we tested temperature, or how temperature affects the reaction of enzymes. Now, an enzyme, that is the catalyst that helps generate needed chemical reactions within the body. This happens from a substrate connecting to the active site of an enzyme, helping create faster chemical reactions. Now, the specific enzyme that we use in our experiment is called trypsin. Trypsin is usually located in the lower intestine of an organism, usually surrounded by temperatures of anywhere from like 35 to 38 degrees Celsius, and there's a pH of 8. Now, in our experiment, the question we asked was, how does temperature affect enzyme activity? And we believe that there was an optimal temperature of 50 degrees Celsius, and everything below that or higher than that, the reaction would slow down, maybe even stop from the denaturing of proteins. Now, as I said earlier, this is our second time doing the experiment, so we had room to improve, and we did this by creating two different things in our experiment this time. And each sample that we did, and each temperature from 30, 40, 50, 60, and 70 degrees Celsius, we had replicates. And when I mean replicates, I mean for each sample of each degree, we did it 3 times. So 30 degrees was done 3 times, 40 degrees, 50 degrees, 60, and 70 degrees was all done 3 times. And we also included negative controls this time. We can get into it later, but this is where I added water instead of TCA into our samples to expect no change. Now, creating the negative controls and replicates, this helped create a more authentic and accurate experiment. Alright, so the first thing we did was add 450 joules of buffer at 8 pH. We chose 8 pH because that is what is found usually inside of an organism. Next, we used 500 joules of azocasine. Azocasine is what reacts with the trypsin and our trypsin alone, which we used 50 joules of. And we did this for each sample with 3 replicates. Now, after this, we incubated the samples for 20 minutes at 30, 40, 50, 60, and 70 degrees to begin our reactions. And right after incubation, we added 500 joules of TCA. The TCA is used to stop the reaction. Now, if it was negative, instead of using TCA, we added water. So there was no expected reaction to it. So we knew nothing would happen. Later creating a more accurate experiment in the end. Now, after that, we placed both the samples and the negatives into a centrifuge for 2 minutes at 12,000 RPMs. Now, after centrifugation, what that did was separate the undigested proteins from the digested proteins. Undigested proteins, you could see inside the tube, was a pellet on the bottom. It was like a solid pellet. On top, the digested proteins are supernatant. It's more of a liquid. Now, after that happened, we used the spectrometer to read the absorbance levels to figure out how the proteins were doing. Now, the first thing we did was blink the spectrometer, 440 nanometers, using DH2O in a cuvette, because using DH2O will give us a absorbance level of 0. Now, after that, we transferred each of the supernatants into a cuvette, which is used to read the absorbance level, place it into the spectrophotometer, and read and record each of our samples. This is our data. I don't know how well you can see that. kind of small, I know, I'm sorry. But, as you can see, maybe not see, I don't know, we found that we had an optimal temperature of 30, and that was where our highest absorbance levels were taking place, was at 30, meaning that's where reactions were happening at its peak. Now, I'm not entirely too sure how accurate this information is, because we did have human error within our experiment. In our 30 degrees here, 2 of them are above a 0.15, while the other is literally below 0.1, creating an outlier. So maybe some of this information isn't correct. Secondly, in our 40 degrees Celsius sample, it has an absorbance level that is literally negative, and that's impossible. A negative absorbance level can't even happen. And you can see this line right here. That is another outlier within our 50 degree mark. It's literally at 0.53, while the other 2 are below a 0.1. But just off this data, I would say optimal temperature was at 30 degrees. Everything to the right with the replicates, I would say, are lower. Now, with our null hypothesis, we found that the absorbance at temperatures of 30 is not significantly different than the absorbance at 40, and so on from 40 to 50, 50 to 60, 60 to 70. There was no significant difference in absorbances at temperatures between them. Now, once we calculated our p-values, each p-value was higher than 0.05. Now, because they were higher than 0.05, we had to fail to reject the null hypothesis for each of them, each and every single one of them. Now, in conclusion, we found that where we set our hypothesis, our optimal temperature would have been 50. Our experiment did not support our hypothesis because, based on the data, optimal temperature is 30. Now, as I said earlier, there was human error. At one point, as we were putting our tubes, we were adding our tubes into a tray. The tray fell, knocked all of our samples onto the ground, and in our 40 and 50 degree samples, we had each temperature had one sample that spilled open, and we had to recreate our supernatant. And then during the incubation stage, there was a time where the incubation stages or the incubation devices were taken up, and there was nowhere for us to put our samples. So we had to leave out our 40 degree sample and our 70 degree negative out for a whole 5 minutes while the others were incubating. They were sitting out doing nothing. We tried to compensate by taking the other samples out, leaving those in for an extra 5 minutes, but that's just how it worked out. Now, based on this entire experiment, after doing it the second time, there is another way we could have maybe made the experiment a little bit more accurate, maybe just being more precise. Don't drop all the samples on the ground, that would probably help a lot. And based on other groups, they found that there was a pH of 9 where enzyme activity is at its highest. So instead of using a buffer of pH of 8, use a pH of 9.